Hello geometry students, welcome back to another video. Today lesson 5-4, angles formed by transversals. And really we're looking at finding the measures of angles and parallel lines and identifying the relationships between these parallel lines and a transversal. Once again, it's going to be a little bit of a longer video, so please bear with me. Take as many notes as you can. We've got 3 new theorems that we're going to introduce that allow us to tell if lines truly are parallel. So in the past, we had these 2 types of diagrams where we had 2 lines, maybe line M and line N, that were being cut by a transversal T, right? Recall that angle 2 up here and angle 6, they are corresponding angles. But at the same time, they're not equal. They can't be equal measures because we don't know that M and N are parallel. If they're not parallel, the measures aren't equal. But they're still corresponding because they're in the top right and top right. We also have a different diagram where the 2 lines are parallel, where M is parallel to N, and it's being cut by this transversal L. Angle 2 and angle 6, they're still corresponding because they're in the top right and top right of each set. So therefore, because the lines are parallel and they're corresponding, their measures are the same. And that's really what the corresponding angles postulate tells us. If 2 lines are parallel, then the corresponding angles are the same measure. Or if the corresponding angles are the same measure, then the 2 lines are parallel. So that's one way we can tell 2 lines are parallel. If those corresponding angles 2 and 6 have the exact same measure, or if they tell us the lines are parallel, I know that 2 and 6 are exactly the same. All right, that's something we've talked about in the past, and we talked about in our last couple of live sessions. Now, based on that, pause the video, or I can't pause it, but answer the couple of questions that are going to come up now. Number 1, angle 3 and angle 7 are blank angles. Number 2, true or false, angle 3 is congruent to angle 7. Why? And number 3, find the measure of angle 3. So hopefully you were able to answer number 1. Angle 3 and angle 7 are what we call corresponding. They're in the same location, so they are called corresponding angles. Both in this case in the bottom right. Are angle 3 and angle 7 congruent? In this case, this is true. How do we know that? It is true because the lines are parallel. How do I know the lines are parallel? And I'm just going to use this symbol for parallel. It's these 2 red marks that tell us the lines are parallel. That's the symbol, right? And because the lines are parallel, we have the corresponding angles postulate. Corresponding angles postulate. As long as I know the 2 lines are parallel, I know the corresponding angles are congruent. What's the measure of angle 3? Well, these 2 right here, 85 and angle 3, have to total 180. Therefore, angle 3 would have to be 95 degrees. If you're confused on any of those, please make sure to reach out and ask. Because now we're going to move into the new material, right? We've got these 2 types of pictures here that are happening. Diagram number 1, I'll put over here. Diagram number 2, we'll call this one over here. And what we have are 2 lines that are being cut by a transversal. We don't know if the lines are parallel. Quite frankly, it doesn't matter at this point. But what we have are A and B that look like they might be parallel that are cut by T. Okay, cut by T. And when we do that, we've got 2 sets. We've got 1 set up here of angles, and we've got 1 set of angles down here, with my T being the transversal. In the other diagram, we've got X and Y. So this is a set of angles, and this is a set of angles. A few of the words that we're going to use in a moment are going to be called alternate, we're also going to use interior, and we're also going to use exterior. And I'm gonna type these because it'll go much faster if we type them. Alternate. Interior, exterior. Same side. Okay. Alternate refers to opposite sides of the transversal. So if I look at, let's just say, this angle up here on the top, this is on the left, so an alternate would be any of the angles on the right. Interior refers to in between the lines. And I'm going to put in between the parallel, even though we don't know that they're parallel. That's what we're looking at, in between those parallel lines. Exterior really means the outside of those parallel looking lines. And the same side means on the same side of the transversal. Okay, so if I'm looking for an alternate interior angle, alternate interior angles, this red one right here is in between. The alternate one would be right here because that's also in between the parallel lines, but it's on the opposite side of the transversal. If I was looking for alternate exterior, right, this is on the outside. It's not in between, so it's on the outside. Alternate means to go to the other side of the transversal and outside over there. So we're going to use these relationships to describe some new postulates and theorems. The first one is alternate interior angles theorem. If we know that two lines are parallel, so if I know M and N are parallel, then alternate interior angles are the same. So 3 and 5. They're on opposite sides of the transversal and they're interior. Angle 3 has to be congruent to angle 5. Or angle 4 congruent to angle 6. So what this theorem is telling us is that if the lines are parallel, the alternate interior angles have to be congruent. Or we can switch that around. If 3 and 5 are congruent, then the lines have to be parallel. Okay, and that's what it's looking at in this one. Now, I'm going to skip that page. We also have the same relationship with alternate exterior angles. Okay, if two lines are parallel, so if M and N are parallel, then angle 1 would have to be congruent to angle 7. Alternate exterior. They're both on the outside of the parallel lines and they're on opposite sides, alternate sides of the transversal, right? 1 and 7 or 2 and 8. As long as I know the lines are parallel, I can say this is true. And conversely, if for some reason I knew that, let's look at this picture over here. If I knew that 2 was, let's say, 40 degrees, and I also knew that 7 was 40 degrees, if I knew that, then I'd be able to say the two lines have to be parallel, because that's what this theorem states. Okay, alternate interior and alternate exterior angles are almost identical. They just use the interior versus the exterior angles to tell whether or not angles are congruent or to tell us if lines are parallel. So here's an example. Let's look at this diagram over here. Angle 2 and angle 8. What would we call them? Hopefully, you notice that those are alternate exterior angles. Alternate exterior. Right? They're on opposite sides of the transversal, but they're on the outside of M and N. If we knew that angle 2, if I knew that this angle 2 was the same as angle 8, then I know that the lines are parallel. How do I know that's true? How can we conclude that? Well, that is the alternate exterior angles theorem. AEA, alternate exterior angles theorem, says that if alternate exterior angles are congruent, then the lines have to be parallel. They have to be. Now, if we also know in this one that M is parallel to M, so now they're telling me the lines are parallel, they're telling me they have to be, and we know angle 3 is 120. 120. We'd have to use that to find the measure of angle 8. Okay? Well, M and N are parallel means that corresponding angles are also congruent. Corresponding angles. So 3 corresponds to 7. So number 7 would have to be 120. Why do I want that? Well, because 7 and 8 are a linear pair, and together they would have to equal 180, leaving us with 60 degrees for angle 8. 60. Okay, so again, I hope you're writing these examples down. I hope you're slowly going through them. Now, the last one we have is same side interior. Same side interior. And as you can see, 3 and 6, they're both in between the two lines, and they're on the same side of the transversal, or 3 and 6 on this one. What the theorem says is that if the two lines are parallel, that angle 3 plus angle 6 have to be supplementary. They have to be supplementary, or that if I add them together, they have to total 180 degrees. And the other way works. If I know that angle 3 plus angle 6 is 180, then we can conclude the lines are parallel. So that's what the same side interior angles theorem is telling us, right? If those two angles interior on the same side total 180, then the lines are parallel, and vice versa. So let's look at this example, right? Another diagram. 4 and 7, right? What do we call 4 and 7? Hopefully you just realized that that's going to be the same side interior. All right, same side interior. So if we know that angle 4 plus angle 7 are supplementary, then we can conclude the lines are parallel. What allows us to say that? The same side interior angle theorem. Same side interior angle theorem. Right? If I know the angles are supplementary and they're both same side interior, then the lines have to be parallel. That's exactly what the theorem is telling us. All right. So if the measure of angle 1 is 82, and they're telling us this line is parallel to this line, find the measure of angle 6. So they're telling us the two lines are parallel. They are parallel, and they're giving us angle 1. Well, angle 1 plus angle 6 would have to total, hopefully you got that right, 180. Those are same side interior. 1 and 6 are the same side interior. And if that's the case, they have to total 180. Well, if angle 1 is 82, that leaves us with 98 degrees for angle 6. 98, because they are same side interior. 98 degrees. So hopefully you got those three relationships down. Alternate interior angle theorem, alternate exterior angle theorem. Remember, those we're working with congruent angles, and then same side interior angle theorem working with supplementary. Read through this again carefully, watch it again if you need to, make sure that you've taken notes, and then make sure that you try the practice problems listed out there today. Until next time, everyone, stay safe.